This is a video on phase diagrams. A phase diagram is a graph of temperature versus pressure that shows the conditions under which the phases of a substance can exist. It also reveals how the states of a system change with changing temperature or pressure. So this is the phase diagram I'm going to explain. This is for water because because all substances are going to have different parameters or different temperatures and pressures, which will correspond to different states. It's going to be specific for each substance. So what I mean is, like, every substance is going to have its own individual phase diagram. So let's look at what this graph means and what information we can get out of it. So first thing I want you to do is to notice there are three curves. We have AB, which is here. Oops. Yeah. There we go. So we have AB, which is here. So this is going to be the temperatures and pressures where you have equilibrium between a solid and a vapor. So this is going to be where sublimation and deposition occur along this line here. Next, we have AC, which is between liquid and vapor. So this is going to be the line that represents the condensation and evaporation processes. And finally, we have AD, which is between a solid and a liquid. So this represents the transition of freezing and melting. So AB indicates the temperature and pressure conditions at which ice and water vapor can coexist at equilibrium. Like I said, sublimation and deposition. AC indicates the temperature and pressure conditions under which liquid water and water vapor coexist at equilibrium. Again, that would be the condensation and evaporation. And finally, AD indicates the temperature and pressure conditions under which ice and liquid water coexist at equilibrium. Again, that being melting and freezing. Because ice is less dense than liquid water, increasing the pressure lowers the melting point. Point A indicates what's called the triple point of water. The triple point is the temperature and pressure conditions at which solid, liquid, and vapor exist at equilibrium. So what you're going to see in this video is a substance called tert butyl alcohol, and you're going to be witnessing this substance at triple point. So you will see many different changes of state occurring because you're going to have equilibrium with all of the changes of state, whether it's boiling, like there, that's great timing. So it spontaneously boils. Remember, boiling doesn't necessarily have to be with heat if you lower the pressure. So here the liquid is in a vacuum, and so that makes that makes the atmospheric pressure inside the flask at 0. So that means that it's going to spontaneously or automatically boil. So now we're going to have the triple point. So you will see both boiling and freezing and all of those things. So there you go. As you see how it's freezing. So it freezes over, and then a little bit later, you see how it's also boiling because you have the bubbles that are occurring. So you'll also have melting and condensation and all of that happening all at the same time. And that's the triple point. Okay, then we get to point C, which is all the way up in the upper right-hand corner. Oops, better turn that off. Did I say triple point again? Sorry, critical point. So, okay. Point C is a critical point of water. Critical point is an indication of critical temperature and critical pressure. So then we have to define what are those things. Critical temperature is the temperature above which the substance cannot exist in its liquid state. So that means it doesn't matter how much pressure you put on that substance is not going to be a liquid. It's just vapor. So water can't be liquefied no matter how much pressure there is. That's critical temperature. Above that temperature, liquid water cannot exist. And critical pressure is the lowest pressure that the substance can exist as a liquid at the critical temperature. So remember I said it doesn't matter how much more pressure you put on the water vapor, it's not going to become liquid. And so the critical pressure is the lowest pressure that it can exist as a liquid. And that is phase diagrams.